pleased to present to you Dana Baril. She is a software engineer with the Windows Defender team, going to tell you about some of the super cool stuff we're doing with Cred Manager.
Hi, everyone. I'm Dana. I'm a security software engineer in Windows Defender ATP. My team is researching new threats and developing post-breach detections for them. And I am here today to introduce you to a project I've been working on with Alan Chan. And in this project, we investigated credential theft out of the Windows Credential Manager. And while investigating credential theft, we discovered a recurring technique that is very challenging to detect. So just to motivate you, this technique was evident in high-profile hacking tools such as Mimikatz. I could even find this meme online about Mimikatz. And it was also evident in some of the major attacks we were seeing in the last few years. For example, we could see this technique in NotPetya attack. It's one of the biggest attacks we had in the last 2 years. And it was a ransomware that was evident in Windows machines. So just to keep the scope of this discussion, we will be focusing on the lateral movement phase today. So just to remind you, as part of the attack lifecycle, we have the penetration phase, where an attacker gains a foothold in the organization. And then we have the lateral movement phase, where an attacker is trying to spread through the network. So we will be focusing today on lateral movement. And actually, we will be focusing on credential theft. So just as a reminder, credential theft is the process of stealing credentials out of the user. So the attacker already has access to one victim machine. He can run malicious code in the user context. And now he is trying to spread through the network, looking for key assets and data. So before we can start, let's do a quick reminder about Windows Credential Manager. So this is Windows Credential Manager. This is the place where we store the user credentials. This is where all of your credentials are stored. The credentials are stored under two different sections. We have the web credentials on the left, and we have the Windows credentials on the right. And if this is the first time you hear about the Windows Credential Manager, you must be surprised that all of your credentials are stored in one place. I mean, why do we even store all these credentials? It's not sound very useful. So if you wonder, the reason we store credentials is in order to avoid password fatigue. Password fatigue is the case where the user is just exhausted of typing his password all over again. So we all have many different accounts. We have Google accounts, we have Facebook accounts, we have lots of passwords to remember, and it can be very exhausting. For that reason, we have one component that stores all of our credentials. Now, the next question you must be thinking, this sounds very useful, but I never use it. So I'm going to tell you today that you're using it all the time. So if you ever mark Remember My Credentials, you use the Credential Manager. We use it for remote desktop connection credentials. We use it for web credentials. So in this example, I just log in to my Facebook account, and the browser suggested me to store my credentials in the Credential Manager. Most people pick Save. OK, so we understand why do we have the Credential Manager. We understand when do we use it. And now the next question is how it works behind the scene. So the credential manager is including two different APIs. We have the Credman API, which is used for Windows credential, and we have the Vault API, which is used for web credentials. The two different APIs are very similar. They have similar behavior. They have similar functions. They include functions such as get credential, find credential, and enumerate credentials. So it all starts when the API sends an RPC request. The client API sends an RPC request with one of the APIs to the LSAS process. LSAS is the process that owns the encryption key of our stored credential. So an RPC request is sent to LSAS. LSAS uses the encryption key and extract the requested credentials, send it back to the requesting app with an RPC message. So this is how LSAS work in general, of course. And we were seeing in the last few years many different attacks on LSAS. So we could see pass-the-hash attacks. We could see an extraction of clear passwords from the LSAS memory. And we could see some other similar attacks. But all of these attacks are already covered. They are covered in ASR mitigations, in the credential guard rules. They are even covered by the ATP detection. So the attacker had to change their approach. They had to find a new way to extract the user credentials. And for that reason, they started to do the following thing. They just pretended to be another app, and they just queried the Credential Manager API. So they just requested kindly our credentials, and LSAS provided it to him very kindly too. So what we see here, I just have to mention that it's not a bug, it's a feature. So what I'm trying to say that this is not a vulnerability. Nothing is broken in our API. The API works perfectly. It provides the credential for a requesting app. The only thing that is broken here is that application can use this API in an abusive way. Okay, so now we understand the threat. And we were trying to create a detection for this threat. It was really hard, by the way. So in order to detect this threat, I'll first explain to you a little bit about Windows Defender ATP EDR. For those of you who are not familiar with the term, an EDR is an endpoint detection and response agent. So unlike EPP, EDR is a post-breach solution. Post-breach is meant for, we understand that even the most secure location can be penetrated. And for that reason, we understand that we have to monitor our devices all the time, even if a penetration wasn't evident. So an holistic security solution is including an EPP, a preventive solution, and a post-breach solution, such as EDR. We will be focusing today on the EDR solution, on the post-breach solution. So our EDR solution is, first of all, in the middle of it, we have our Windows 10 agent. The Windows 10 agent is already embedded in Windows 10. The agent is responsible to log everything that happens on the machine. It is also responsible to collect forensic data, such as machine state, and it is also has remediation capabilities. The agent knows where to send the data to because of an organization certificate, which is installed during the onboarding process. The second part of our EDR solution is our cloud detection. So the agent logs everything that happens on the machine, and we run cloud-based detection later. So just to say that again, we have a security solution that includes a cloud-based detection and an agent. Okay, so at that point, we understand what EDR is. We understand our security solution. We understand the threat that we have on the credential manager. And we are trying to combine these two together. We are trying to create a detection for the threat we just saw. So at that point, we were looking for relevant logs. We were looking for relevant telemetry, relevant ETW events that can indicate that a credential was read from ELSA's memory. We were looking for such events in ELSA's documentation. We were looking in the event viewer for the different events, and we couldn't find any relevant event. We couldn't find any indication that a credential was read from ELSA's. For that reason, we realized that we need to develop our own new event. And this is what we did. So if we'll go back to the chart I presented before about how ELSA's works, we decided to add a new event as part of ELSA's process. So every time when a credential is read, when ELSA's is queried for a new credential, we have a new event logged. This event is logged in the event viewer in the security section. And it's going to be available in RS5 in our next release. And you all can use it. You can all see that very soon. So this is how an event looks like. The event includes the used API. So we can see whether it was a credential read and enumeration of all the credentials. We can also see the number of the read credentials in this API call. And the most important part for us, we can also see the requesting process information. So we can know which process requested this piece of credentials. I must emphasize at this point that the event does not include your passwords. It only indicates that a credential was read. So no secrets are available in this event. So before we move to the next part, I want to show you how it works. So this is the Windows Credential Manager. We can see the two different sections here. Here is a Windows credential, and here is a web credential. You're all going to see my passwords very soon. That's OK. This is the event viewer. You can see all the different events here in the security log. I am clearing the log. I am running Mimikat. Mimikat enumerates all of my credentials. You can now see all my passwords. You can see my Windows credentials passwords. And if we scroll up, we can also see my web credentials password. Mimikat just queried ELSA's API. If I'll go back to the event viewer, to the security log, and refresh it, we are now going to see new events coming in. So the event indicates on the API that was used for this credential read. And we can see the number of the returned credentials. We can see the initiating process. We can see the requesting process, the requesting application here. So at that point, we have an event that consumed by our agent. So we get indications that the credentials are read. And now it was the time for us to detect when an abusive use of this API is happening. So that was the time we were looking for our detection strategy. We began looking on our newly collective events, and we got thousands of events every day. We were looking for a way to pinpoint only on the abusive usages of the API. Out of these thousands of events, only a fraction was an indication of abusive usage. So we thought for an effective solution that will help us to detect this threat. I won't be able to reveal here my secret sauce, but I can share with you some of my thinking process. So first of all, we verified that only a certified apps is reading their credentials. So for example, remote desktop connections can be read only by relevant apps, only by remote desktop apps. And Office credentials can be read or certified to be read only by Office apps. In addition, we verified that web credentials are read by browsers and other relevant web apps. In addition, we verified the requesting process signature and its prevalence. On top of that, we also ran a machine learning-based detection. So we managed to create an accurate solution, an accurate detection for this threat in this way. So just to summarize, we learned a little bit about Windows Credential Manager. We learned about its uses. We saw some of its internals. We saw how a new threat came into the Credential Manager API. We learned a little bit about Windows Defender ATP, about the cross-breach concept. And I also showed you our detection strategy, which included a new development of OS telemetry and a cloud-based detection. So before I'll move to the questions, I just want to thank a few people here. So first of all, I want to thank to Alan Chan, to Mark, to Parnav, to my team, to Inbaraz, and to my dear husband, Daniel, who supported me. So I'm ready for the questions.
Hi. You mentioned everything was great, thank you. So I'm wondering if, because you mentioned that there's work being done on the detection side of things, and I'm wondering if there's also some collaboration with the Windows Store guys to do some sort of static analysis for when these APIs are being abused and preventing at least Windows Store apps from being accepted in the Windows Store, so that we don't even get to the point in which we need to detect these anomalies as they are running. We simply stop the apps from being present on users' computers.
Yeah, OK. So as I said, this is not a bug, it's a feature. So I'm not aware of any work from their side, but it doesn't mean that it's not happening. I'm just not aware of any of this work.
It works. Nice presentation. I have a question that seems to be obvious. I mean, like when you are talking about extract credential from LSASS, we know for sure that like when you LSASS is not able to like extract the Windows credential. I mean, not the Windows credential, but the credential, the password that you have inserted like when you log in to your computer. So this is why we have introduced the LSA ISO that is isolated in like in another domain. So I was curious to understand when you ask to LSASS to extract the credential of web or like some other user credential, they are yielded in like in clear or like in hashed.
OK, so as you could see in the demo, when I used Mimikatz, the password was extracted in a complete way. You could see my password completely. So you could see not only the hash, but you could see the password entirely. Is that answers your question?
Yep, more or less, yes. But like, what I would like to understand is that, for sure, for the user and web credentials, they are there should be an API that call for SS and ask the plain credential. But for the Windows credential that you insert, usually Mimikatz, if I don't remember wrong, is able to decrypt the hash because it's reads from the LSASS memory. So if you put LSASS in through Credential Guard in another security domain, Mimikatz doesn't work anymore and extract only the hash. I'm wondering if it's still the same case for like a user and like web credential, or is different?
Yeah. So yeah, first of all, what you mentioned is right. The clear text is there only in a certain context. And wait, what was your question again?
No, if the API that you can call for extract the user credential, return like the password in clear. That's it.
Yeah. So I want to make sure that I understand your question. I can definitely do a follow-up with you later on.
Okay. Thanks.
Hello. Nice presentation. Thank you. I have a question. For your project, you only log every credential read action, right, in the event log. But for the end user, they seldom look the event log. Do you have some plan to show some warning alert on the desktop? That's my question.
Yeah. So I know that the EPP solution is also working on detection based on the same event. So yeah, that's a work in progress.
Thank you very much for that. Adding the event log. Previously, we tried to do this with DP API, and it was just a mess. So thank you very, very much for that. Do you know how often that event will be logged on normal computers? Is it like a fire hose? Is it very selective? How often do you see that happening on most computers that have it enabled?
Yeah. So of course it depends on the user usage. So I don't have one good answer for you, but we see these events in an average case. We see it quite a lot. For our detection solution, we created some filters and some aggregations, so we won't have to handle all of the events. But in general, in the event log, we have plenty of new events every day.
Okay, thank you.
Hello. Sorry in advance. Someone in the front row asked me to ask a question for you. But how do you detect credential decryption by DP API, by example, especially when you use RPC protocol and we don't use the normal API?
Yeah. So this is not part of the scope of this talk today. So I won't be able to answer this question.
Hello. Thank you for the talk. It was wonderful. I had a couple questions about your ML pipeline and the analysis that you mentioned at the very end. I know you cannot go into a lot of details, but just out of curiosity, what's your false positive rate in terms of determining whether it was actually a malicious process trying to extract credentials or a legitimate process trying to extract credentials? I'll ask follow-up questions afterwards. Yeah.
Okay. So I'm not a machine learning expert. I'm a software engineer, and for me, machine learning is still a magic. So I don't have any good answer for you, unfortunately.
Okay, no worries.
We have some machine learning experts in the crowd, so they might be able to answer later.
Okay, I'll ask my follow-up questions to those guys. Thank you.
Hi, thank you for the talk. I saw a demonstration earlier about Credential Guard, and when it is, successfully implemented, turned on and all that stuff, then Mimikatz is not able to do basically what you demonstrated. Can you differentiate how Credential Guard and the new feature are kind of providing security on the endpoint?
Yeah, I won't be able to get into too much details. But first of all, in the demo, you could see my machine running with the Credential Guard and with Mimikatz in the same time. So, we definitely block in many cases this specific scenario, but the specific scenario I used wasn't blocked by the Credential Guard.
Got it.
There is lots of differences between the Credential Guard and our solution, and we make sure that we try to detect cases that are not already covered in the Credential Guard.
So this is one more layer on top of Credential Guard in case it can't keep up.
Yeah, I'm not sure what was the scenario used in the Credential Guard talk, but for sure it wasn't the same one I used here.
Yeah, thank you.
So this is definitely a great security feature that you just introduced. For the event logging, that's obviously useful for forensic analysis. So for the EDR piece, as far as detection and response, if a customer has WDATP all turned on and enabled, what would be the interaction for user? As far as, is there any particular alerts, or is it all like automatic in the background? Other than the event logging piece.
Our detection capabilities are running in the cloud. So for our security solution, the alerts will be in the cloud and not on the client machine.
Right, so it's like the Security and Compliance Center or other places, or just like the WDATP console, or, for this type of alerts and events?
Yeah, so the alerts are in the ATP portal, yeah.
Thank you.
So for customers that don't connect to the internet or can't connect to the internet, what are we going to see?
It depends on their security solutions, first of all, because if they're not connected to the internet, they should have a server based in their organization so we can run detections on this org, on these events from this org. So as long as we can run our detections, that works.
Hello. So to complement his last question, once the process determined that this app is potentially malicious, this is treated like a regular malloc and blocking further invocations of this application. This spreads to all Windows ATP and Office 365 ATP clients.
So what is the question?
No, the question is if these detections, based on this new event ID, once they are determined as malicious, they are treated as a regular malloc. So they are blocked in further calls, or yes?
It's not blocked, it alerts. So we have a detection that alerts on a malicious activity. The EDR solution at this point is not blocking. We have remediation capabilities, but that's a different topic here.
Yes, but you now know that this app is potentially malicious. So will it be prevented to be executed once the next time?
Yeah, so that's part of our remediation capabilities. It's exactly one of those. We are still working on our remediation capabilities, but that's definitely one of those.
Okay, thanks.
Does anybody else have a question? Because we have plenty of time. Oh, 1, 2 in the back.
Hey, great talk. I had a question around in the testing and in the deployments that you have. You're trying out this feature. What's the considering ideal scenarios where internet connectivity and everything is up? What's the average response time for the alert to be flagged off once the detection has been caught?
It depends on lots of things, as you said. But in the ideal case, it will take less than 2 minutes.
Okay, thank you.
My question is more around the eventing that got added to it. Will this be like a reg key that we have to add? Is there any documentation about this yet? Is it part of security policy that'll be added in RS5 or what?
So we are planning to post in the security blog a post about this.
So as far as mitigation, would that be a like built-in capability in the WDATP and then somehow connecting to the client, or does the customer have to use some sort of EPP to block once there's an alert?
Okay, so that again, you're talking about our remediation capabilities, right? Yeah. So unfortunately, I won't be able to answer that as part of this talk.
Are there plans to backport this feature to previous versions of Windows 10 and possibly Windows 7?
That's a great question, actually, and it's still in discussion. We really want to backport this ability. We don't have any plan, like any strict plan right now.
Any roadmap or anything? It's still discussion?
Yeah.
Okay.
But yeah, maybe you can help us with this discussion. Convince the right people.
Well, I'm in sales. So I'd love to advocate on behalf of my customers who'd probably be asking for this. So yeah, thank you.
Thank you for the great talk. You said that you were logging the client of the Credential Manager RPC call. How do you intend to authenticate that Chrome is Chrome and that it's not a fake Chrome or code injecting inside Chrome or Outlook or any other client application?
So we have many ways to authenticate an application or a service. And we use mostly the SHA-1. Yeah.
Not the DLLs, not the code running in a... Sorry, not the DLLs, not injected code into the binary. Only the binary that is Outlook.exe. Only the SHA-1 of this one.
So yeah, as I said, we have many ways. That's the major way to authenticate.
You make it too easy for Mimikatz to steal passwords.
We have some other authentications way. Yeah.
Hey, perhaps it's like a remark and not a question. Just the last question actually kind of touched on one of the other questions that was asked here. Basically, if someone injects somewhere, let's say someone inject to Chrome something and Chrome's try to do something else, you can't basically rely on remediation, right? You don't want to like block an injected process that was tampered somehow and tried to steal credentials. So this is for remediation. Just wanted to remark that. Thanks.
Going once, twice. All right, please give another round of applause to Dana.